OK, so I know why you're here. So let's get to it. Let's get to the end. You want to know who's the best, whether it's Require, or Webpack, or SystemJS, or Browserify. So the results are here. And the winner is La La Land. So the good answer is that there is no good answer for this question, and this is what this talk is all about. My name is Opher, and I'm a creative developer at a company called Echo, where we do a platform for interactive videos. And as you might have guessed, I might have seen Star Wars once or twice. And this is by far the nerdiest talk I've ever given. So let's see how that goes. So what is packing or bundling, and why do we even need this thing? And let me answer this question with another question. What if the Death Star were to be built as a web app? So let's break it down. You have your super laser, because you need to destroy planets somehow. And you have your trash compactors, and you have your turbo lasers, and you have power generators, and you have a social network for stormtroopers. OK, so no frameworks, no anything, just pure JavaScript. Let's start talking about modules. So what are modules? Modules are self-comprised pieces of code that deal with one topic, one thing, in a self-contained way. So let's do this with plain JavaScript. You have deathstar.html. And for each of these different modules, you have your own JavaScript file. So you have superlaser.js, and you have turbolaser.js, and so on and so on. And these have to be styled, of course. So you have different style sheets for each of the different components. And maybe you're a bit more advanced. So you're using a preprocessor like Sass or Less or Stylus, whatever you want. So you have one style CSS for your entire Death Star. OK, so doing this, it's not too bad. I mean, there are some advantages to working like this. First and foremost, you don't need to know anything new. If you know JavaScript, if you know CSS, yeah, you can totally run with vanilla JavaScript. You can totally code like it's 1999. That's up to you. But it has some disadvantages. Mainly, module communication this way is done via globals. So if one module wants to talk to another, it will have to register a variable or a function on the global scope, pollute the global scope, and generally create a mess. You have a huge list of these dependencies to manage in one HTML file. So this list will surely get unruly. And if you're several developers working on the same thing, you'll be stepping on each other's toes all the time. Sorting out dependencies will get really difficult, because if you have module A that needs module B, and module B also needs module A, which one do you put first in your HTML? OK. And like we saw earlier in Anna's talk, multiple HTTP calls for each and different asset that you need, which is a bad thing. So, doing this, when you think of it, might be like a good idea at first. But like lots of other things that seem like good ideas, reality is a lot different. So that's why we have different tools that help us deal with these issues. The first, which we're going to talk about, is Require.js. Require.js was developed in 2009 by James Burke. And in a way, it's kind of similar to Yoda, because it's quite ancient in terms of software development, at least. It packs a punch. I mean, it has lots of features that can and do solve these problems. And it can teach us a thing or two. I mean, a lot of other tools were based on the knowledge that was gathered from Require.js. But it also uses odd syntax and cryptic messaging. So uncaught error, mismatched, anonymous, defined module function definition named global is an error that up to this day I'm not really sure what it means. How do you use Require.js? So you have your deathstar.html, in which you have a script tag that points out to the require runtime, but also has this data attribute that points out to your entry file. And then in your app, in your deathstar.js, you have your require function, which defines its dependencies. So in this case, superlaser is a dependency. And then you have a callback, which once this dependency has loaded, you can use it. So in this case, superlaser.destroyPlanet, Alderop. Perfect. So why do we even have this callback? What's this thing? So Require.js works out of the box asynchronously. That means it makes an AJAX call to your asset and then gets it, and only then executes this callback. So it does this using something called AMD modules, or asynchronous definition models. So this is how an AMD module looks like. You have your define function, which says this is a model, these are my dependencies, in this case a beam crystal, and a callback, like we saw earlier. And then you have private functions, prepare laser, public functions, and destroy planet, and then the return function, which tells the module what it exports. In this case, it's the destroy planet function. OK, so earlier on, we discussed multiple HTTP calls. And why is that a bad thing? Well, there was an excellent talk about that earlier. But in a nutshell, if you have 3 different dependencies, PowerGenerator.js, SuperLaser.js, and TractorBeam.js, then you'll have 3 separate calls for each of these dependencies. So each and every call has an overhead associated with it. That might be OK for 3 files or 10 files, but for 100 files or more, that's a lot of bandwidth being wasted on overhead with HTTP 1.1, because we learned something today. OK, to solve this, what can we do? So one solution is to take all of these files, different files, and combine them into one giant pile of JavaScript that's concatenated called bundle.js. And this way, you have one request for this, bundle and one response getting all these files, regardless of the number of files. OK, so Require.js has some advantages. First, you can use it in an asynchronous manner, like I showed you earlier, and also in a synchronous manner with a tool called the RJS optimizer, which takes all of your files and creates a bundles like you just saw. It also allows you to do uglifying and optimizing. What is uglifying and optimizing? It takes your beautifully handcrafted JavaScript code that is just a joy to look at and turn this into a mangled, horrible thing that people can't read, humans can't read, but your browser can read just fine, and it's less bandwidth, less data to move down the wire. But Require.js isn't perfect. It has a long and winding configuration file that's really quite a hassle to edit. It has a bit of a confusing documentation. And you either get a giant JavaScript file in the end. But that's not the downside of Require.js as much as the downside of bundling in general. And you also have to write AMD modules, because that was the way it was designed. OK, giveaway time. This is how it's going to work. I have little small Star Wars figurines that you can win as prizes. And all you need to do is answer a JavaScript question. And whoever answers the question the loudest will get these figurines. Are you ready? One guy's ready. Are you ready? OK, this is the question. In JavaScript, array plus array equals. Someone said true, which isn't the true answer, but let's see. I hope they have insurance. OK. Someone says empty string, and that is the right answer. Array plus array equals empty string, because JavaScript. OK, back to the talk. Next tool we're talking about is Browserify. So Browserify, wait, there's a logo. The idea behind Browserify is to leverage the strength and ecosystem of Node and NPM from the server-side node to the browser. And Browserify is kind of like, it was developed 2012 by James Halliday. And it's kind of like C3PO in a sense that it transforms one language into another. And it also breaks down into smaller pieces. In this case, it's the NPM modules, which together form together to create this one bigger, better thing, which is your app. So how do you use Browserify? You have your devstar.html, and then you point out your script file to your script tag to your bundle. And that's pretty much it. No, but seriously, the idea here is that Browserify is a command line tool, so all the magic happens at compile time, at build time. So how do you do this? You have your Browserify command, which you run. It takes an input, your devstar.js, your output, which is the bundle file. And then in devstar.js, you do var superlaser or let superlaser if you're into ES6 now, and require superlaser as if you do it on the server side with Node. Then you can directly in the next line use superlaser.destroyPlanet. So this happens synchronously. You don't have to wait. There's no callback. How does this happen? So Browserify works with CommonJS. So let's contrast this with AMD, which we saw earlier. So CommonJS is the way that Node uses module, which is a different syntax for doing the exact same thing. So instead of define, we don't have that. For dependencies, instead of the callback function, we have the require. And the other difference here is that in order to tell the module what to export, you use the module exports reserved keyword. So that's CommonJS versus AMD. Browserify also has the notion of transforms, which are little pieces of code that allows you to take one input and turn it into some sort of output. So you have, for example, Babelify, which turns ES6 code into vanilla ES5, CSSify, which allows you to require CSS files, and Uglify, which minifies code. I don't condone this naming convention, but essentially you run Browserify with your input, devstar.js, output bundle.js, and the T flag for whichever transform you want. So Browserify definitely has advantages. First of all, it's super simple to set up and lightweight because it's a command line tool. So there's no configuration. You just type the command you want, and that's it. It uses NPM modules. It allows you to use NPM modules both in the server and in the browser. So things that previously were only available in the server, like streams, event, buffers, you have shims for that from the server to the browser, so you can use them in the browser. But let's talk about bundles again for a bit. So let's say you have two pages. Page A uses PowerGenerator.js, needs PowerGenerator.js, and SuperLaser.js. Page B needs PowerGenerator.js and TractorBeam.js. OK, so you manually create these two distinct different bundles, bundle 1 and bundle 2. But now what happens when a user visits your page A and then the user visits your page B? So they download these two bundles, and that essentially means that they downloaded PowerGenerator twice. You have duplication here. Your user downloaded something twice that he shouldn't have because he already downloaded it once. So that's one major disadvantage when working with manual bundles. When you define these bundles, not only do you need to worry about actually dividing them in a way that makes sense, if you do it in a way that doesn't make sense, you get your users to download things that they don't need to download. So disadvantages of Browserify. You have no asynchronous require, because again, Browserify works synchronously. You have your input code, you do the compiling, and then you have your bundles. It relies on CommonJS packages. They are our way to make Browserify work with other types of modules, but out of the box, it's aimed at CommonJS. And you either get a giant JavaScript file at the end, or you get bundles with replicated code, which is not perfect. Moving on to our next tool, which is Webpack, which was started to develop in 2012 by Tobias Koppers. And Webpack is kind of like Han Solo. In a sense, because it gets the job done in its own way. Webpack is very, very, very opinionated. That's not a bad thing, but it is a thing. It shies away from commitment. because it works with both AMD modules, CommonJS modules, and ESX modules. It doesn't care, likes them all. And it also comes in two flavors, old and new. Old being Webpack 1, and new being Webpack 2. And hopefully Webpack 2 won't get murdered by its wayward son. How do you use Webpack then? You have dev-start.html pointing out to bundle.js, like before. And you have superlaser, require superlaser, exactly like you saw before. What's the difference here, though? Now you have require for a style sheet in your JavaScript. What? You have style sheets in your JavaScript? That's what you might say, because that's how you sound in my head. So yeah, the idea here is that modules don't only contain code. They contain other assets that you might need for your app. So that might be style sheets, that might be images, that might be, I don't know, 3D models, whatever. It's all self-contained in one module, in one unit. And Webpack allows you to do that with types of pieces of code called loaders. So let's see how would you build something with Webpack. You have your configuration. This configuration defines the inputs, the outputs, the plugins, and the loaders, which I just talked about. And you have your, you run Webpack, which takes this configuration and works with it. And you get, again, your bundle.js of compiled code. Here's a cool feature of Webpack. Webpack code splitting. Code splitting comes to solve the problems of manual bundle management. The same problem that we saw earlier when you have to define these bundles yourself. So how does that work? Let's say you have your dev-start.js, and you know the dev-start has a dependency for the superlaser, but you don't need it right now. You don't need to destroy Alderon just as the page loads. You can just wait a bit with that. So you can use Require.ensure, which has a similar code to what we saw earlier with Require. So you have Require.ensure superlaser with a callback function, and as soon as that asset loads, as soon as superlaser loads, then you can use that code. Here's the cool thing about that, though. If you define this in your code base, and run Webpack, Webpack will create separate bundles depending on where you decided to split your code. So in this case, you'll get maybe bundle.js, and then bundle.1.js will take only the code defined in this code split. So you don't have to manually declare all your different bundles. Webpack does that for you, which is nice. Another cool feature that I like about Webpack is static analysis. So static analysis is something that it's not often talked about in terms of browser-side development, but it's an old use in server or software, general software development. So the idea is this. Let's say you want to make sure that you don't have any glaring holes in your apps, which might lead to its destruction based on flaws in design. So you can take a look at what exactly was created at compile time. And Webpack has this tool that allows you to look at the output of your bundles of what was made during a compilation phase and exactly see what was going on. Which module needed which module, which dependency led to which dependency, and also the sizes of these dependencies. So this way you can know at runtime, at compile time, before any users visited your web page, you can know if a module requires too many modules. You can know if maybe someone put an asset that is too big and didn't minimize it. You can know that at this stage. So Webpack definitely has advantages. It allows you to load AMD, CommonJS, and ES6 modules. It allows you to import assets like images or SAS or CSS, whatever. It allows both synchronous and asynchronous loading. And it allows you to build the bundles without having to worry about it, because it does it itself. And the last thing is static analysis, which we talked about earlier. OK. But it's not perfect, because nothing is perfect. Webpack is definitely more complex to set up. configuration, loaders, things to install, Webpack 1, Webpack 2. There's a lot to learn there, so there's a lot to shoot yourself in the foot with. But you need to put some effort into gaining something. It can't load non-Webpack modules. So let's say you have a different JavaScript module somewhere out there in a CDN that wasn't packed with your project. You can't load that with Webpack because Webpack needs to know all the code that you're planning to have in your app during compile time. And the documentation could be better. But the documentation for Webpack 2 is much, much, much better than the documentation for Webpack 1. So kudos for the Webpack team for stepping up their game. OK, giveaway time. We do this the second time. This one, I want more enthusiasm. And like again, I said, my aim is bad. So if you said the right answer and didn't get your prize, that's too bad. OK, so type of not a number in JavaScript. Oh, wow, that's like, I just have to throw this randomly. OK, I didn't get to that side, so that side's also going to get some. And the other side as well. And let's... OK. Number. The type of not a number is a number. Because JavaScript. SystemJS. SystemJS is the last tool we're going to look at. It was developed 2013 by Guy Bedford. And SystemJS is a bit like Ray. In a sense that it's very forward-looking. It's very modern. It is new to the story. And it comes with something that handles packages. Oh, it's true, that one is going to go so much better. In this case, it's JSPM.io. So also doesn't need your help, and great comedic timing by me. We talked about HTTP 1.1, which I need to fix here. And we saw how if with HTTP 1.1, if you have a lot of files leading to a lot of requests, you have a lot of overhead. So HTTP 2, based on the Speedy protocol, aims to solve that. It does this by, instead of bundling everything together, it allows you to send essentially one request, and then with all the files that you eventually need to get. And then the HTTP 2 connection allows you to multiplex all of these files into the stream that you're going to get back. So you have 3 separate files. These are completely separate files, but you have one request going out and 3 files coming in on the HTTP 2 stream. So now you don't have to send all these different requests, saving on all this bandwidth. OK, let's see how you'd use SystemJS. OK, so you have devstar.html. This is a simple example, where here in script src, I pointed out to the JSPM CDN to get the SystemJS runtime. In the script, I use system import. And here's the cool thing here. I pointed out to GitHub. So that's a really cool feature of JSPM. JSPM is both a package manager and a package delivery service with a dedicated CDN. And it allows you to use JSPM as a package manager, kind of like an analog to NPM. You can use GitHub, you can use NPM, you can use whatever. JSPM is kind of a focal point for all of these different repositories. And the sources are sent minified over HTTP2. So the JSPM CDN already supports HTTP2. And then you can just specify your dependencies, and it already has them minified sent to you via HTTP2, which is cool. But you don't have to use things from the web, things from GitHub or whatever. You can roll your own code, which is what most of you will do. How do you do this? You run JSPM install, which creates your configuration file and the SystemJS runtime. And then in devstar.html, you reference this SystemJS runtime, the configuration time that was created, and you do system import for your devstar.js. And that's cool because you can have the option of either bundling your code like we saw earlier. You can do code splitting with SystemJS as well. And you can use the HTTP2 CDN to, if you don't want to do that, if you're more looking into the future of JavaScript or the future of JavaScript distribution, then you could be using these to work with HTTP2. So the advantages for SystemJS is that it's really potentially performant with no bundling needed, because we're working with HTTP2. And if there's no bundling, then there's no bundle management issues, so you don't even have to solve that. You can still bundle, though, if you want to, using the JSPM builder. And you can load those directly from GitHub or NPM or JSPM, whatever you want. The disadvantages, again, because no tool is perfect, is that using two package managers is kind of weird. Because you need to start with npm install to install JSPM. That's kind of like using Internet Explorer to download Chrome in the old days. It currently relies on a polyfill for ES6 modules, because SystemJS is really aimed at future JavaScript ES6 modules. But the good news is that browsers today are really far advanced with implementing ES6 native, so the day where we have native ES6 in browser is really not far. And it requires HTTP2 support both in the browser and in the server. So most browsers today already support HTTP2 over HTTPS, but that also means that the server needs to support HTTPS, so there's more configuration to be done, so there's more things to be done, so that's something to consider when you're asking yourself which tool to use. It also requires a deeper understanding of packaging and bundling, because like I said, the process is more involved, so you need to know more about the pipeline here. Just a caveat, there's no way I could have covered all the features, all the problems, all the solutions to all of the tools. So the answer to which tool to use is pick whatever you think is right and what makes you happy. So I know that's not a really good answer. Maybe that's the good answer you were looking for. But what is a tool that makes you feel happy? Try, download it, read a tutorial, use it for 30 minutes. If you think it's OK, go ahead and use it. If it makes you happy, go ahead and use it. If you hate it, just don't use it. And it's as simple as that. Don't be afraid of learning. I know that in our field, there's like a new JavaScript library coming out every minute. And it's hard to keep track of all these buzzwords and new technologies. But that's not a bad thing. That's a good thing. The fact that our field is always progressing and changing, that gives you the opportunity to learn. And you don't have to know anything, but you can learn as much as you want. And that's a really, really good thing. That's a thing that, that should inspire you and not frighten you. Because Yoda once said that fear leads to anger, and anger leads to hate, and hate leads to flame wars on GitHub. So don't be one of those people that defend their favorite product with zeal, that go out to the forum and say, no, that is good, that is bad, and you should use what I use because reasons. Because you only end up not convincing anyone of anything, not being right, and being quite annoying in general, like this. Use the tool that makes you feel powerful. And if you feel powerful, then your code is happy, you're happy, and everyone else is happy. Thank you all for being with me. I'm on Twitter, on GitHub, on website, on the web, every site that has a username and a password. If you have any questions, I'll be around here in the conference. I'll be the tall guy that you recognize because I stood here and gave you a talk. Thank you.